Hi there, my name is Jacob Coleman, and today I will be presenting my research paper entitled Concepts for a Prefabricated Wall Panel to Increase the Uptake of Straw and Pure Wool Insulation in New Zealand, co-authored by Hans Christian Wilhelm. Straw and pure wool are the only bio-based insulation materials produced in New Zealand and are abundant in New Zealand as raw materials. However, straw and pure wool insulation have incredibly limited uptake in New Zealand due to the success of straw-insulated prefabricated panels from overseas from the likes of Modcell and EcoCocoon. Prefabrication was investigated as a means of increasing the uptake of straw and pure wool insulation in New Zealand. This research paper also recognises the gap or absence of a bio-based insulated prefabricated wall panel in New Zealand, although notable research in the area continues to be done in New Zealand into straw bale prefabricated panels. Therefore, 3 straw and pure wool insulated prefabricated wall panel concepts are proposed in this paper. The concepts are informed by literature and precedent review and are reviewed and compared in terms of their weight, thermal resistance, and vapor resistance. In this presentation and in the paper, the term bio-based is used to refer to materials that are both from renewable sources and biodegradable. We need bio-based materials because they reduce end-of-life waste, consumption of finite resources, energy consumption, and greenhouse gas emissions. No straw or pure wool insulated prefabricated wall panels exist in New Zealand. Straw insulated prefabricated panels are produced in the UK and Lithuania by the companies Modcell and EcoCocoon respectively. However, no prefabricated panels using pure wool insulation are produced anywhere globally. In New Zealand, experimental prototypes of straw bale insulated prefabricated wall panels have been developed. Additionally, prefabricated wall panels that use wool blend insulation are produced in New Zealand by EcoPanel. Straw bale prototype prefabricated walls have been developed in New Zealand by Sole Design in 2011 and 2014. More recently, in 2019, researcher academic Min Hall produced 4 prototype straw bale wall panels at 1/3 scale. The EcoCocoon is used as a base for the prefabricated wool concepts. The panel designs are all of the consistent dimensions of 0.35 meters by 1.8 meters by 2.4 meters to allow direct comparison. Data is sourced on the materials used in the proposed panel designs to compare the weight, thermal resistances, and vapor resistances. The calculations have been manually conducted. Wool is more insulative and less dense than straw, making it the superior insulation material. However, the increased density and bearing capacity of straw means that it has the benefit of being able to support heavy plaster renders. Clay plaster is a bio-based material and is highly vapor permeable, which is ideal for bio-based insulation materials as it allows them the ability to dry out. Therefore, there is an opportunity to maintain the presence of straw in a prefabricated panel as a substrate for the vapor permeable bio-based material of clay plaster, despite the thermal advantages of wool insulation. A hollow timber box beam for the top and bottom plates minimizes thermal bridging and provides separate cavities that require insulation. This provides an opportunity for pure wool insulation within a prefabricated straw panel. A prefabricated pure wool wall panel should be constructed similarly to a straw wall panel and use a vapor permeable sheathing as an alternative to a plaster render. Gypsum sheathing is the most suitable sheathing material for this purpose, as it is more vapor permeable than a magnesium oxide sheathing. Gypsum sheathing comes in two forms, one for exterior use featuring fiberglass and/or waxed paper coating, and one for interior use. Here is the data regarding the properties of the materials. A standard prefabricated timber frame is used for each design. The timber frame weighs 169.5 kilograms. For each design, a pure wool bat insulation product that can hold its shape is proposed along with compressed straw. Panel 1 is comprised of the timber frame filled with compressed straw insulation and with pure wool insulation present in the hollow timber box beams used for the top and bottom plates. The vapor and thermal resistance for this panel are calculated through the straw and clay plaster on the exterior and interior. Panel 2 is identical to panel 1, apart from 150 mils of pure wool insulation instead of straw in the center. Straw is present on either side of the wool insulation as a substrate to the clay plaster. Rigid self-supporting compressed straw panels will be glued into the prefabricated timber frame on one face before the pure wool bat insulation is laid in the frame and sandwiched between identical straw panels on the other face. The vapor and thermal resistance for this panel are calculated through the straw, wool, and clay plaster. Panel 3 is entirely insulated with pure wool bat insulation, with gypsum sheathing in the exterior and interior. The vapor and thermal resistance for this panel are calculated through the wool insulation and gypsum sheathings. Here are the manual calculations. Here are the calculated weight and thermal and vapor resistances of the panels. Panel 1 only makes a minor alteration on the existing prefabricated straw panels such as EcoCocoon and Montcell, with the addition of pure wool insulated top and bottom plates. Panel 1 is therefore the least speculative of the three designs. Panel 1 combines wool's low density and superior insulative properties with straw's ability to support the bio-based vapor-permeable material of clay plaster. It is therefore more insulative than panel 1 and more vapor-permeable than panel 3. Panel 2 occupies a useful middle ground in terms of vapor and thermal resistance. The presence of clay plaster on panels 1 and 2 does make the panel significantly heavier than panel 3. However, a crane can easily be used on site. Panel 3 is a pure wool insulated substitute for the Eco panel. As expected, panel 3 is the lightest and most insulative of the three designs due to the exclusive use of pure wool insulation. However, panel 3 forgoes the ability to support clay plaster and as a result suffers a mild reduction in vapor permeability compared to panels 1 and 2, which can support clay plaster. The design proposals presented in this study are purely conceptual. Aspects of their designs, such as window and door openings, location of surfaces, and connections to adjacent panels, walls, floors, and roofs, have not been developed as yet. Additionally, numerical simulations or physical prototypes of the designs have not been undertaken. Hydrothermal simulation will provide verification of the design's hydrothermal performance in New Zealand's climate. In addition, physical prototypes will be essential to carry out physical testing. A feasibility study would also be valuable to determine the viability of the panels. Also, a life cycle assessment, as well as calculations of the embodied energy and emitted CO2 of the panels, would also further this research and provide an understanding of the environmental impacts of this panel. Thank you for listening.